Well, here we are. It's finally the last week of our learning at home, so this will be the last video lesson. Feels like it went by pretty quick, but we do have one more to go. So this is a pretty short one though, so we'll go ahead and jump right into it. It's about the dual nature of light. All right, so the dual nature of light. So scientists for a long time tried to figure out what light was. So scientists like Newton attempted to prove that light was a particle. And he pointed to behaviors such as reflection and refraction, and both of them supported that hypothesis. So reflection, very obviously, is just like throwing a ball at a wall and it bounces off. Refraction, so takes a little bit more of an explanation. So as a particle goes into the medium, it experiences a force, and that bends it. And then as it comes out of the medium, it experiences the opposite force. So it bends again. This is how Newton explained refraction. And he did a demonstration using prisms that he believed proved light was not a wave. The prevailing belief at the time was that light was a wave that degraded as it entered things, and that's why light became a rainbow when it went through a prism, because it was degrading into all the colors. Newton used two prisms to show that you can go from white light, rainbow, back to white light. So he said, hey, it's not degrading, it must be a particle. Well, unfortunately, another scientist named Christian Huygens theorized that light waves could also do these things. He said light waves could also reflect, and they could also refract. And he's correct. So we're left basically where we started. Is it a wave or a particle? Well, then we get to Young's double slit experiment. So scientist named Thomas Young, he shined light through a single slit, so very small opening. If light is a particle, you would expect there just to be a single line of light on the wall because these particles of light went straight through this slit and they hit the wall. That's not what you get. Here is a single slit. You can see the wave, the light has kind of spread out as it entered the slit. Instead of getting this nice thin line of light, you get this spread out line, like blob of light. This is not what people were expecting if light is a particle. So what's happening is light is behaving like a wave and bending through this opening. Then he tried with two slits. And what ends up happening is, so here's the single slit up at the top on this picture. The light comes in and it's going to bend to get through this slit. And when it does, instead of moving in a nice straight line like it was before, you now have this bent light. Once it reaches these two slits right here, it can now enter them. And when it does, it's going to bend again. But now you have bent light wave on the right, bent light wave on the left. Well, waves, when they encounter each other, they interfere with each other. We talked about this weeks ago. Interfering means they can either add up and make a bigger wave, or they can add up and make a smaller wave. So you end up getting these alternating areas where it's brighter and areas where it's darker. So brighter is where they've added up to make a bigger wave, brighter light. Darker is where they've added up to a smaller wave, or smaller wave, they are dimmer. So this is the famous interference pattern that you see when you shine light through a double slit. This is something only waves could do. Particles would not interfere with each other. But two tennis balls, when they hit each other, they don't just boom, produce a bigger tennis ball or produce no tennis ball. They bounce off each other. You would not get this pattern if light behaved like a particle. This is a wave-only behavior. This is something Young's double slit experiment proved. So you would think, all right, well, I guess we have the answer. Light's just a wave. Unfortunately, we have some other smart guys who pop up and prove other things. We have the photoelectric effect. So the photoelectric effect is what happens when certain frequencies of light are shined on certain metals. When that happens, the light can actually go in and knock the electrons out of the metal. Well, electrons are particles. A light wave wouldn't do this. This is a behavior of a particle, especially in how it presented. It would have to have presented in a very different way for this to be a wave behavior. Now, something very important to remember about the photoelectric effect, the electrons, when they get knocked out, they now are given energy by that collision. So they have kinetic energy, and their kinetic energy depends only on the frequency of the light that hit the metal. So the frequency of the light is very, very important. So this right here in red, very important. Maybe it's on your quiz. Now, this was observed, but it took a little while for someone to come along and explain it. Thankfully, we have Einstein. So Einstein explains this by describing light as being made up of small packets of energy called photons. You've probably heard the term photon before. If not, it's a pretty important word. Make sure you learn that. So Einstein actually won his only Nobel Prize for describing the photoelectric effect. He's done numerous other things, general relativity, kind of a big deal. He didn't win a Nobel Prize for that, but he did for the photoelectric effect. So this helps support the particle theory of light, not the wave theory. So once again, we're kind of at a toss-up here. Which one is it? Is light a particle or is light a wave? Well, it's both. So this was titled The Dual Nature of Light. Light can act both like a particle and a wave. Light is very, very special. Light can do both of these things. We literally have a constant called the speed of light that nothing can go faster than. So when light's traveling through space or interacting with itself, it's acting like a wave. But when light interacts with other matter, it acts like a particle. So that's where the photon nature of it comes into play. So light can do both. It acts like a particle or a wave. It just depends on the situation. And that's everything you need to know for your last quiz. So if you have questions, please post them in Google Classroom, email me. I'll be available on Thursday. I'll post your last quiz tomorrow. Make sure that you catch up on all the quizzes up till now. I will post links to all the quizzes next week. So all the quizzes will be just in one post for you to access there. And I guess this is the last video, so I can't say I'll see you in the next one, but like and subscribe anyway.